Okay, this is the start of 8.5. Identify and generate equivalent algebraic expressions. Let's look at this first part right here. We're going to evaluate when x equals 6. So the whole thing is to see if when I solve this problem, then solve this problem if they come out equivalent. Equivalent meaning that they're the same answer. Okay, so if x squared, what is x squared minus 5x when x equals 6? So we're going to plug that in. So I have 6 squared minus 5 times 6. 6 squared is 36. 5 times 6 is 30. Oh, they did not want us to solve that yet. I'm sorry. Let's put that 6 in. So we bring our 36 down. 5 times 6 is 30. 36 minus 30 is 6. So if they're equivalent, this one over here will also be 6. So let's plug our 6's in. 6 minus 5 is 1. Let's bring our 6 down. 6 times 1 is 6. Both of the answers are 6, so the expressions do have the same value when x equals 6. We're going to do about the same thing that we did above, but this time when s equals 8. So this says 4, and in parentheses we have s over 2 plus 2s. So we're going to put 8 in. We're just going to drop this 8 down, and we're working over on this first. 8 over 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 4, that says a 4. 4 times 4 is 16. So 16 plus 16 is 32. Let's see if this one's the same. We're going to put 8 in. 4 times 8 is 32. Since this is 32 and this is 32, they do have the same value. The next thing we're going to look at is right down here. It has our properties on it. Equivalent expressions are expressions that have the same value for all possible values of the variable. Of course, you can't check every possible value. Fortunately, there is an easier way to show that expressions are equivalent. You can use the properties of operations. If you can apply the properties to one expression to get the other, then the two expressions are equivalent. So we have several properties here. We have the commutative property, the associative property, and the distributive property. The commutative property, you can do this with both addition and multiplication. It just means that if I have 2 plus 1, I can flip my numbers around, and it's the same thing. If I'm multiplying, I can flip my numbers around, and it's the same thing. The associative property groups things with parentheses. There's always going to be 3 numbers or 3 letters, and it does not matter how you group them together. It is going to get you the same answer. This only works with addition or multiplication. If you see it with subtraction, division, it does not work. The distributive property, I like to call the friendship property because whatever this number is on the outside of the parentheses is going to multiply with the numbers on the inside. It's forced friendship from the guy on the outside to the ones on the inside. Okay, let's look at this next part. Identify the properties used to determine the expressions are equivalent. So if I look right here on the first one, we're going to check to see what they did. So we have 4a, and then in parentheses, 2a plus 2b, and then 4 plus 4a. And then this is what we have on the other side. So we're going to see if this is the same as this. So the first thing that they did is they took the first one and they changed it into this. To do this, they did 4 times a is 4a, and 4 times 2b is 8b. That means they used the outside number and they multiplied it with the ones on the inside. So that's distributive property because they went and multiplied with the numbers on the inside. Next, what they did, if you look at it, this is 4a, but then they switched these around. and that is the commutative property. Now I'll let you do an abbreviation of that because otherwise it's not going to fit on there. What happened next was we took the parentheses and we put those in there, but how they did it is they took the A out. So they took the A out and left the 4, so that's distributive again. I don't really like what they did here, but we're just going to go with it. Then they took 4 plus 4 and got 8. So we add the inside of the parentheses. And they took the 8 out and put it on the outside, so that's distributive. So did we end up with the same thing that we did up here? Yes, we did. Most of your ones will not be like that, don't you worry. You're not going to have to label going back and forth what you did. Okay, now we're going to see on this one if we can get this to be that. So the first thing that they did here is they took the X and the Y, since it's the same on the both of them, and put that on the outside, and we're going to leave the 8 and the 5 because we can't do anything with that. And we get this is the distributive property. We're going to add 8 and 5 together. And when we do that, we get 13. And 13xy is not the same as 3xy. Like terms are terms with the same variables raised to the same exponents. So you can only add like terms. That means if they're s's, like down here, you can only add things that have s with them. If there's, say, like an n, you can't put the end in with it. And they go down very elaborately on this. It really doesn't take that much, and you'll see that when we get around to that in the other ones, once we get past this first section. So the first thing they did right here is they just put the parentheses in different areas, so that's associative. Please do not abbreviate this. If you do choose to abbreviate it past the first 3 letters, please, so you don't have any inappropriate words on there. So I would do ASSOC and then put in a period if you don't want to write the whole thing out. Okay, next, what they did is they took this one and dropped it all the way over there. That means I can put things in different order and it doesn't matter, so that's the commutative property. Then we got all the S's together, meaning we regrouped them, so that's associative. So if you're going to abbreviate associative, I would abbreviate it like that. Next thing is what they did is they took the S out and that left it with ones. So that's distributive property. And we are left with 1, 2, 3 S's. 2 plus 1 is 3. Now, that is way more elaborate than I would have done. I'm going to change my pen and I would show you what I would have done at the very beginning. So I'm going to have 1, 2, 3 S's. So that's 3S plus 1 and 2. That's 3. I would have been done in one step right there. And I'm totally cool with doing that. If you want to break it down elaborately like that, you can. But if it's not making you, I would not do that because it gets rather complicated. Okay, let's look at the next one. Are the expressions 6w plus 3z plus 4w plus 7z and 8, and then in parentheses, w plus z equivalent? And the expression 6w plus 3z plus 4w plus 7z, the term 6w and 4w are like terms because they both have a w at the end. To be like terms, it has to have the same letter. And the terms 3z and 7z are like terms. So they're breaking this down for us. What they did is they put the w's next to each other and the z's next to each other. So that's changing the order, but changing the order does not change your outcome. One is adding or multiplication. What they did here is they took the w out, and then here they took the z out, so just let's put the 3 and the 7. That is distributive property. So 6 plus 4 is 10. 3 plus 7 is 10. They took the 10 out and we're left with WZ. And that is distributive property again. So it does not equal the same thing because one is 10 and one is 8. And again, I would not have gone down that far with that much. I would have said, hey, this is the same, this is the same. 6W plus 4W is 10W. 3Z plus 7Z is 10Z. I notice that there are 10s in both of them, so I'm going to take my 10 to the outside, leaving me with a W and a Z on the inside. That way is a lot quicker. Okay, check understanding. If you want to do this in your books on page 263, or bear with me right here. Rewrite the first expression to determine whether the expressions are equivalent. So in this case, we have different letters, but since I can take the highest number that can go into both of those are 4. 4 times 2 is 8. 4 times 1 is y, so that's what I get there. This does not equal this. If you don't like changing it this way, you could say 4 times 2x is 8x. 4 times 1 is 4. And again, not the same thing. I could have known it's not the same thing to start with because this has a y in it. This one does not have a y, so this one is not equivalent. Okay, we're going to use the distributive property. We're going to make the outside number be friends with the inside numbers. 3 times k is 3k. 3 times 3 is 9. So 3k plus 9 is equivalent to 3k plus 9, so that one's equal. And our last page, we're on What Do You Remember? So remember on What Do You Remember, you're going to want to try it by yourself. Hold on one second. You're going to try it by yourself, and then you're going to play it to see what you can do. So the first one, what property of operations is used to show that 12x plus 6w is equivalent to x and then in parentheses 2x plus y? That is the distributive property. Because I can I can pull a 6 out of 12 and 6 and pull it off to the side. Write an expression that is equivalent to this. So I'm going to go ahead and I'm going to use the distributive property. 5 times d is 5d. 5 times 2f is 10f plus 5d. Now I'm going to add like terms. This has a d on it and this has a d on it. So 5d plus 5d is 10d plus 10f. I cannot go farther than this because they have different letters on them. But If I wanted to go a little bit farther than this, I could. I could take a 10 out and left with the D plus F. I would be okay with either one of these. Okay, our next one is 8w squared minus 3w squared, and you can see that they both have w squares at the end, so I actually can just subtract this just how it is right here. This next one, if I look at the ending of all of them, some of them have different endings. This one's p to the third, this one's p squared, this is p to the third. So I can take this one and add it to these 6, meaning I have 7p cubed plus 2p squared. And that is my answer. Find an equivalent expression using the distributive property. So 25 and 30, I know 5 can go into both of those, so I'm going to put 5 on the outside. 5 times 5 is 25, and I'm going to add my w in. 5 times 6 is 30, and I'll add my x back onto it. So that is our answer for that one. Let me scroll back up to the top. Determining if this expression is equivalent. Both of these have m's on them, so I can add them together. 4m plus 3m is 7m, so it is equivalent. This one down here, I can see that I have a 3. I'm going to take my 3, let me go this way. I'm going to take my 1/4 and go this way. So I have 1/4 times 8. That gives me 2j plus 1/4 times 12. That gives me 3k. Now, this starts with a 3j. This is a 2j. This is not equivalent. Let's take a look at our next one. I have an x here, and this has an x, so I have a 1x here. I have 7 here. That's 8x plus 5. Okay, this next one, we're going to use the distributive property. 2 times x is 2x. 2 times 4 is 8 minus 5. 2x does not get to do anything because it has an x on it. 8 minus 5 is 3, so that's my answer for that one. We're going to use the distributive property. So x times 4 is 4x plus x times y is xy. And that is our answer in all of Module 8.